Welcome to Starry Academy. I hope you're fine. I hope you're good. Today we'll be looking at number-based system. A number-based system. At the end of this class, you should be able to write number base in the expanded form. In other words, you should be able to expand number-based system or a particular number. Secondly, you should be able to convert a number from one base to another. You should be able to convert number base to decimal. Decimal means to base 10. You be able to convert to base 10 and convert from base 10 to other numbers. You be able to perform operations such as addition, subtraction, multiplication, and division of number-based numbers. So let's commence. If you can do all this I've listed at the end of the class, then you are good to go. Now let's talk about expansion and conversion of number-based system. What is a number-based system? It's a system that deals with numbers in their various bases. A system that deals with numbers in their various bases. Now, take for example a wall clock. The highest number you can see in a wall clock is 12. So even if you want to count to 13, you want to count to 50, then you have to rotate around 12. So when you get to 12 noon, and you get to 1, your 1 is a 13, your 2 is a 14, your 3 is a 15, your 4 is a 16, your 5, that's why 5 p.m. is 17:00. So it means the clock operates by a number in base 12. Yeah, it's 12 because the highest number you have is 12. Once you get to 11, you're back to 0, 0. Yes, your fingers also. Your fingers operate. Your fingers, we have 5 fingers. Yes, 5 fingers. If you want to count over 5, you have to go back to the first finger to continue at 6, 7, 8, 9, 10. Then go back to the first finger again and then count 11, 12. That's how it works. Yeah, this is a picture I'm showing you right now. Number-based system. So we have the base 3, base 4, base 5, base 6, base 7, base 8, base 9, base 10. We have the hexadecimal base. The highest number in base 3 is 0, 1, and 2. The highest number in base 2 is 0 and 1. So an example of a number in base 3 is 1, 2, 2. 1, 2, 2. Yeah, 1, 2, 3. 1, 2, 2 base 3. Because it is not possible to have a base and have that number in the figures, which means that when a number is in base 3, for example, the highest number you have is 2. The numbers can't go beyond 2. So it's 1, 2, 2 base 3. In base 4, you have 1, 1, 4. Base 4, it has to be the highest number there has to be 3. So you can't have 4. So you have 1, 3. 1, 3, 3. Base 4. Now you got what I'm trying to say. When you have a base, your figures cannot be more than your base. When your figures are more than your base, then just know that you are already solving the wrong thing. Take for example this 1, 2 is also wrong. You can't have 4 to 5 base 5. Rather it will be 3, 4, 2, 4, then base 5. The highest number of a number in base 5 is 4. You can't have base 5 and still have that same number among the figures. It's not possible. So you have base 6. The highest number in base 6 is 5. This one is correct, acceptable. Base 7 is also acceptable. Base 8 is acceptable. Base 9 is acceptable. Base 10 is also acceptable. So expanding numbers. How do we expand numbers? Decimal numbers are numbers in base 10. Decimal numbers are numbers in base 10. So let's move to the next slide. How do you expand? You have 4,321. This 4,321 is the same thing as 4,000 plus 300 plus 20 plus 1, and 4,000 is the same thing as 4 times 1,000 plus 3 times 100 plus 2 times 10 plus 1 times 1. In other words, you can also say that 4 times 1,000 is 10 raised to the power 3 plus 100 is 10 raised to the power 2. 10 is 10 raised to the power 1, and then 1 is 10 raised to the power 0. So if I can expand these numbers this way, it means that there is a principle that guides the extension of numbers. The unit here that I'm pointing to right now carries the power of 0. The tens carries the power of 1. The hundreds carries the power of 2. Thousands carries the power of 3. According to place value system. Then a number in base 2 can also be written in the same way. If a number in base 10 can be written this way, then let's try out the number in base 2. The number in base 2, 1101, one I gave you right here, 1101 base 2. How do you expand this? Like I said before, the unit carries the power of 0, the tens carries the power of 1, 100 carries the power of 2, and thousands carries the power of 3. So how do you expand? 1 times your base 2. 1 times 2, this 2 here, this 2. 1 times 2 raised to the power 3 plus 1 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. Now what you have just done is you have just expanded this number. Now let's check for more examples on board. Okay, we have first we just keep one example. Let's go back to check it out. 3103 base 4. 3103 base 4. Yeah, to expand this, you have 3. This 3 carries a power of 0. This is a unit. Your unit carries power of 0. Your tens carries the power of 1. 100 carries the power of 2. 1000 carries the power of 3. So you have 3 times your base 4 raised to the power 3. 1 times your base 4 raised to the power 2 plus 0 times your base 4, not 3, times your base 4 raised to the power 1 plus 3 times your base 4 raised to the power 0. Now what you have just done is you have just expanded this number. Let's check out other examples that we can expand. I believe by now you should be getting the logic behind expansion of numbers. So we have 110011 base 2. How do you expand this? I already gave you the tactics of expansion, that for you to expand you need to check out your base, look at the place value system from your unit to the highest place value. So the number that we have now on board, 110011, is a number that is beyond thousands. Now let's check out the place value of 110011 base 2. The highest place value, let's check from here. 1, your unit carries a power of what? 0. 1 carries a power of 1, that's your tens. 0 is your 100. Another 0 is your 1000. This one is your tens of thousand. This one here is your 100 of thousands. So your power increases. So what do? 1 times your base power your power, plus the second one times your base power 4, 0 times your base power 3, plus 0 times your base power 2, plus 1 times your base power 1, plus 1 times your base power 0. You have successfully expanded this number. You have another example, 2710 base 8. You expand 2 times 8 your base power 3, plus 7 times your base power 2, plus 1 times your base power 1, plus 0 times your base power 0. With these examples, I believe that by now you should have caught up with this first objective, expansion of numbers. So let's talk about converting to base 10. How do you convert a number to base 10? There are 2 steps in converting to base 10. Just 2 steps. The first one is expand the number, like we have learned before. We just finished learning expansion. Now after expanding the number, you simplify what you have expanded. That way you'll be able to convert to base 10. Base 10 is a normal natural number. So let's check out the examples we have. Don't forget the steps to convert to base 10. Number 1, expand, and secondly, you simplify your expanded form. Now let's look at the examples that we have. The first one we have is 3103 base 4. I said to convert to base 10, the first thing you do is you expand. When you expand, 3 times your base power 3, plus 1 times your base power 2, plus 0 times your base power 1, plus 3 times your base power 0. Yeah, so this place is 3 times 4. Yeah, 4 power 0 is 1. Is 1. So from what I wrote here, 4 power 3 is 64. So what do you do? Now students make some mistakes. And what is the mistake? The mistake is that I've seen students who multiply before they find the power. Now what you ought to do first is to find the value of 4 power 3. Do not multiply before putting the power of 3. No. Find 4 power 3. The result you get, you then multiply. That is how to do it. So 4 power 3 is 4 times 4 times 4. 4 times 4 times 4 is 64. Plus 4 power 2 is 4 times 4. That's 16. 1 times 16 plus 4 raised power 1 is still 4. That's 0 times 4 plus 4 raised power 0 is 1. Now listen, anything raised power 0, any number that has the power of 0 is 1. This is a law that is extracted from indices. Any number that is raised to the power of 0 is 1. Take note of that from now henceforth. So you have 3 times 1. So let's simplify. 64 times 3 is 192. 1 times 16 is 16. 0 times 4 is 0. 3 times 1 is 3. And then successfully you have converted a number from base 4 into base 10. You have 211 base 10. 211 base 10. Alright, let's work out in second example. 2, 7, 1, 0 base 8. I can't say 2710 because it's not in base 10. I can only call it that way if it's in base 10. So because it's in base 8, I have to call it like 2710. So let's expand. The steps in converting to base 10 is expand, then simplify. So let's expand. If we expand, we are going to have 2 times 8 raised power 3. Why is raised power 3? Because your unit carries a power of 0, your tens carries a power of 1, your 100 carries a power of 2, your 1000 carries a power of 3. So 2 times 8, your base, raised power 3, plus 7 times your base, raised power 2, plus 1 times your base, raised power 1, plus 0 times your base, raised power 0. 8 raised power 3 is 512. That's 8 times 8 times 8. 8 times 8 is 64. 64 times 8 is 512. So you have 2 times 512 plus 7 times 64. That's 8 times 8 plus 8 raised power 1 is still 8. 1 times 8 plus 8 raised power 0 is 1. 0 times 1. So you have 2 times 512, that's 1024 plus 448 plus 8 plus 0. So at the end of the summation, you're going to have 1480 base 10. In base 10, you can choose not to write the base. In fact, if a number is in base 10, you can choose not to write the base at all. Like here, the one I typed here, I didn't write the base, I didn't put the base, I just wrote 1480. So base 10 is the only number where you are permitted not to write the base. If you want to, if you want to write the base, you can write it. If you don't want to, you might not write it, because base 10 is a natural number. It's part of the numbers we use in our daily life. Buy goods, buy food, buy this, buy that. So 1480 can be written without the base. It is permitted, but only in base 10. Only in base 10. So you have the last number here. We're looking at 110. So what is this value? What is the value of this number in base 10? This is a number that is in disguise. This number is in base 2. In base 2, it means a particular value of number or quantity of number. But what is the quantity of this number in base 10? Yes, the highest power there is 100,000. The base value of this one is 100,000. So how do we get our powers? From unit 0, tens, 1, 100, 2,000 to 10,000, 4, 100,000, 5. So we have 1 times your base, that's 2 raised power 5, plus 1 times your base raised power 4, plus 1 times your base raised power 1, plus 1 times your base raised power 0. Now you will notice something. I skipped the 0. Yes, I just skip the 0. Why? Because when you observe from the examples we've been having before, every places where the 0 fails, we always have 0 at the end of the day. Check the first example. We have 3103. Now look at this 0 here. Trace it to this place. What did we get eventually? We got what? 0. Now look at the second example. What did we get eventually? Look at it. We got what? We got 0. In other words, when you have zeros between numbers in number base at the end of the expansion and simplification, you are going to have 0. So instead of wasting your time and ink writing the zeros, yeah, you can skip it. But when you skip the zeros, skip the zeros with the powers. Skip the zeros with the powers. Don't just skip the zeros, you skip them with the powers and then move to the next number. So that is why I have 5410 as my power. 1 times 2 raised power 5 plus 1 times 2 raised power 4 plus 1 times 2 raised power 1 plus 1 times 2 raised power 0. So let's proceed. 2 raised power 5 is 2 times 2 times 2 times 2 times 2, and that's 32. 2 raised power 4 is 16. 2 raised power 1 is 2. 2 raised power 0 is 1. So in other words, you have 2 plus 16 plus 2 plus 1. So at the end of the day, you have 51 is 10. So the summary of this part is that to convert to base 10, what you need to do is first expand first, then simplify your expanded form. I trust when you do this, you are not going to have errors in simplifying or converting a number to base 10 or decimal. Base 10 is also called decimal. If you don't want to call it base 10, you can call it decimal. So what is the relationship between number base and the place value system? If you hear me clearly, or if you heard me clearly the other time when I was speaking, you will discover that I was mentioning unit, tens, hundred, thousands, and all that. Now I'm giving an example here. If A, B, C, D, E, F, G, H, A, B, C, D, E, F, point G, H, I, if they are numbers, what are their place values? This is my unit. My unit is 10 raised power 0. That's 1. This is my tens. My tens is 10 raised power 1, and that's 10. That's 10. My D is my hundreds. My 100 is 10 raised power 2, and that's what 100. C here is my thousand. A thousand is 10 raised power 3, and that's 1000. B here is my tens of thousand, and that's 10 raised power 4. That's 10,000. A here is my 100,000. That's 10 raised power 5. 10 raised power 5 is 100,000. Now you see. What about numbers after decimal point? What are they? Numbers to decimal point. The first number after decimal point is called your tenth. Not tenth now. Tenth is the opposite of tens. The opposite of tens is tenth. So if tenth is 10 raised power 1, then tenth is 10 raised power minus 1, and that is 1 over 10. Hundredth. If 100, the positive one, is 10 raised power 2, then this with 10 raised power minus 2. This power of 10 are going to be our powers in number base. These powers are going to be operating on the numbers, and that's what we use when we are expanding. We use the power of place values on those numbers. So 100 carries the power of minus 2, and that's 1 over 100. 1 over 100. Thousand carries the power of minus 3, and that's 1 over 1000. Now you have seen the relationship between numbers, especially when they have decimal point. And why am I taking you here? I'm taking you to this place because we are about to expand a number in decimal point. So if everything I've given you is understandable, you know the place value of A, B, C, D, E, F, and then G, H, I. With the powers I've explained the other time on each number, then if the powers are like that and A, B, C, D, E, F, G, H, I is in base 10, we are assuming that A, B, C, D, E, F, G, H, I is a number in base 10. Then I'm going to have A times 10 raised power 5, B times 10 raised power 4, C times 10 raised power 3, D times 10 raised power 2, E times 10 raised power 1, F times 10 raised power 0. Now crossing over to the decimal part, your tenth, G times 10 raised power minus 1, H times 10 raised power minus 2, your thousandth, I times 10 raised power minus 3. That is how number based expansion works. That is how it works. You look at the power before you start solving at all. The power determines the place value of the number. Now let's check out this number. 1011.101. 1011.101. First, let's find our units. These are units. The number before the decimal point is your unit. The unit carries the power of 0, tens carries the power of 1, 100 carries the power of 2, 1000 carries the power of 3. After the decimal point, you have tenth carries the power of -1, 0 carries the power of -2, 1 carries the power of -3. This is how it works. So let's expand. I already told you to convert a number from one base to another. Try to base 10. If you want to convert to base 10 especially, you have to first expand, then simplify. This is what you do if you want to convert to base 10. Now let's expand. 1 times the base 2 raised by 3. Skip the 0. Skip the 0 because your final answer will still be 0. If you use 0, if you simplify the 0, you still get 0. So skip the 0 and move to the next. When you skip the 0, you also skip the power. You skip the 0. Why? Because the 0 will still give us 0. 0 times 4 is 0. So instead of stressing yourself, let's skip the 0. Now move to the next number. That's 1 times your base raised by 1 plus 1 times your base raised by 0 plus, now to decimal part, 1 times your base raised by -1. Skip the 0 plus 1 times your base raised by -3. 2 raised by 3 is 8. You have 1 times 8 plus 2 raised power 1 is 2. 2 times 1 or 1 times 2. 2 raised by 0 is 1, so you have 1 times 1. 2 raised power -1 is 1 over 2 plus 2 raised power -3 is 1 over 8. How am I doing this? How? Now let's check few random rough sketch. When you have a number that carries a power in the law of indices, if you have a raised power -1, the answer is 1 over a. If you have a raised power -2, the answer is 1 over a raised power 2. In other words, to remove the minus, to remove the negative power that is disturbing us, we need to make it to reciprocal. So when you have a negative index, a negative power, your answer will be 1 over the positive. 1 over the positive. So what am I saying? In this case, I add 2 raised power -3. So my answer will be 1 over 2 raised power 3. And that's 1 over 8. I guess that's understood how to deal with negative index in number base. So 8 times 1 is 8. 2 times 1 is 2 plus 1 plus 1 over 2 plus 1 over 8. And then you find LCM of 2 and 8. LCM of 2 and 8. LCM of 2 and 8 is 8. 2 in 8, 4. 4 times 1 is 4. 8 in 8, 1. 1 times 1 is 1. If you add this together, you're going to have 11 whole number, then 4 plus 1, 5 over 8. In decimal, your answer will be 11.562. So basically, in this expansion of decimal numbers, what's more important is the powers. Target the powers. If you don't miss the powers, if you do not miss the powers, then you take cognizance of what you are calculating, definitely you won't miss the solutions to the problem. So we've been talking about converting to base 10 all the while. Now, how do we convert to other bases aside base 10? I already said that to convert to base 10, there are two things you do. What's the first thing? You simplify, you expand rather. The first thing you do, you expand. After expanding, what do you do next? You simplify. To convert to base 10, you first expand, then simplify. But now we're talking about converting to other bases. Now take note of this. If you are being asked to convert to other base, if the number you are given is already in base 10, then divide directly throughout with the required base. For example, you are being asked to convert to base 5, that means you are going to divide through with 5. No matter what the number is, you divide all through with 5. This solution is only when you are converting to other base. If the number you are given to convert is already in base 10, then divide through with the number you are converting to. But if the number you are given is not in base 10, the first thing you do then is to convert it to base 10. Convert the number to base 10, then you can now divide all through. Now let's check out what we have here. You have 211 base 10. Convert to base 4. You want to convert a number from base 10 to base 4. So this time around, you are not simplifying, you are not expanding, you are not doing expansion and simplification. What you do is divide all through with 4. Why are you dividing all through with 4? Because you want to convert to base 4. So let's check out what we have. We have 211. Want to convert 211 to base 4, so we're using 4 throughout. 4 in 21, 5 remainder 1. 4 in 11, 2 remainder 3. So 4 in 211 is 52, remainder 3. Use 4 again. 4 in 5, 4 in 5, 1. 4, 1 remainder 1. 4 in 12, 3 remainder 0. There is no remainder, so you put 0. Now you use 4 again. 4 in 13 is 3. You have remainder 1. 4 in 3 is not possible. 4 cannot go in 3 because 4 is greater than 3. So because 4 can't go in 3, you write 0 and then you put your 3. So 4 in 3 is 0, remainder what? 3. Answers are picked from the base. So you have 211 in base 10 is 3103 in base 4. So this settles it. Divide through by 4. Now, but what about when the number you are given is not in base 10? If you are given a number that is not in base 10, then the first thing you do is to convert it to base 10. Now, look at what we are looking at. We have 350 base 7, convert to base 2. Now, the question is asking you to convert a number from base 7 to base 2. If you are converting from base 7 to base 2, like I said, the number is not in base 10, it's in base 7. So what do? You convert first to base 10, then from there you convert to base 7. You are only permitted to convert directly if the number you are given is in base 10. But because this one is not in base 10, it's in base 7, you must first convert to base 10. So in other words, you have 3 times 7, your base is power 2. That's because 2 carries the power 2, 3 is 100, and 100 is power of 2, plus 5 times 7 raised power 1, plus 0 times 7 raised power 0 is 5, not 3. Seven raised power 2 is 49, plus 7 raised power 1 is still 7, plus 7 raised power 0 is 1. 49 times 3 is 147. 5 times 7 is 35. 0 times 1 is 0. So 147 plus 35, you're going to be having 182. Now what you have done is that you have converted 350 base 7 to base 10. So what do you do next when you convert to base 10? Now you can now do what the questionnaire wants you to do. It wants you to convert to base 2. So the thing or the idea or the whole idea is that to convert a number that is not in base 10 to another base, you must first convert to base 10, then convert to the base you are being required to do. So now let's convert a 182 that was given birth from 350 base 7. You want to convert that 182 to base 2. So when you are doing this, make sure you always use a ruler. I can't use a ruler, I don't have a ruler here. So you have 2. I'm using 2 because I want to convert to base 2. So I have to use 2 throughout. 2 in 18, 9. 2 in 2, 1. There is no remainder. Remainder 0. 2 in 9 is 4. Remainder 1. 2 in 11 is 5. Remainder 1. Use 2 again. 2 in 4 is 2. 2 in 5 is 2. Remainder 1. 2 in 22 is 11. No remainder. Remainder 0. 2 in 11 is 5. Remainder 1. 2 in 5, 2. Remainder 1. 2 in 2 is 1. Remainder 0. 2 in 1 is not possible. 2 can go in 1, so it's 0. Write your 1, remainder 1. And then what do you do next? Let's write our numbers from the base. We have 1, 0, 1, 1, 0, 1, 1, 0. So you have converted 350 from base 7 to base 2. That's the bottom line. When you want to convert a number that is not in base 10 to base 2, you first convert to base 10. Then after converting to base 10, then you cannot convert to base 2. The number you are asked to express. I hope you're getting what I'm saying. I hope you understand what I'm trying to put across to you. So now we are moving to the next phase of this class. Remember I said that at the end of the class, if you're able to convert from one base to another, you should be able to add, perform operations such as addition, subtraction, multiplication, division. You understand what I'm saying? So you understand what I'm trying to say? You should be able to add and subtract, multiply, divide in number base. So what are we looking at? In addition of number base, 1 plus 1 is 10. 1 plus 1 is 10. Actually, 1 plus 1 is not 10. 1 plus 1 is 2. But in base 2, that's binary numbers. Binary numbers are numbers in base 2. From the word bi. Bi means 2. So talking of numbers in base 2 now. 1 plus 1 is 2. But we don't say 2 in base 2 because the highest number is 1. Base 2 numbers or binary numbers deals with only zeros and 1. So what do? We convert that 2 to base 2. If you convert 2 to base 2, you have 10. 2 into 1 minus 0. 2 in 1, 0 minus 1. So you have 10. That is why 1 plus 1 is regarded as 10. 1 plus 1 plus 1. If 1 plus 1 is regarded as 10 and it's actually 2, 1 plus 1 plus 1 is 3, but it's being regarded as 11. So instead of converting all these things, just commit them to memory. That 1 plus 1 is 10. 1 plus 1 plus 1 is 11. 1 plus 0 is 1. That one is normal. 0 plus 1 is 1. Normal. 1 plus 1 plus 1 plus 1 is 100. 100. What about when you have 0 minus 1? When you have 0 minus 1, like they used to say, borrow 1, it becomes 10. 10 minus 1 is 1. 10 is actually 2, so 2 minus 1 is 1. But we say 10 in number base. Understand? So now let's do some additions. Let's rock these binary numbers. So we have first question on addition. We have add. We have add 1 1 0 1 1 and then 1 0 1. We're supposed to add this together. I already said 1 plus 1 is 10, so 1 plus 1 10. Carry 1. If 1, I just carry plus 1, it's still 10. Carry 1. 1 plus 1 is 10 again. Carry 1. 1 plus 1 is 10. Carry 1. 1 plus 1 is 10. So the answer is in base 2. I believe you understand what I just did. You can go through it again. 1 plus 1 is 10. Once you add, you carry the 1 to the next number and then add it. So let's move to the next example. Next example, subtract 101. Subtract 101 from 10000 base 2. So you are going to add 10000 minus 101. Now I told you before, I said that if you have 0 minus 1, you borrow 1. If you have 0 minus 1, you borrow 1. I said it when I was talking about this place. Yeah, I said it here. This place. You borrow 1 and then it becomes 10. That 10 is actually 2, not 10. So what do? 0 can subtract 1. So we go borrow 1 from this guy. This guy becomes 0. However, we can't take the 1 here. So what do? The 1 comes to the next number. That's 2. Borrow 1 from 10 becomes 1. Some becomes 10. Borrow 1 from 10. That's 2. Becomes 1. Some becomes 10. Some becomes 1. 10. 1. 10. So you have 10 minus 1. 1. 1 minus 0. 1. 1 minus 1. 0. We have 1 and then 1. So this is how to subtract in base 2. So we have another set of number here. We have evaluate 101101 plus 111 minus 10101. Now ideally you can't do everything together, so you have to start from somewhere. So pick it from the addition. Let's add first, then whatever we get we subtract. So we have from here we have 1 0 1 0 0 plus 1 1 1 plus 1 10 carry 1. 1 plus 1 10 carry 1. 1 plus 1 plus 1 is 11 carry 1. 1 plus 0 1 1 0 1. So you're going to have this. From your addition, this is what you have. Then from here you can now subtract. You can subtract. Now let's subtract the next value. We got 1 0 1 1 1 0 0. This is what we had. Then let's subtract this. We have 1 0 1 0 1. 0 can subtract 1, so you borrow 1 from this guy, it becomes 0, so it becomes 10. Borrow 1 from him, it becomes 1, so it becomes 10. 10 minus 1, 1. 1 minus 0, 1. Now, unfortunately for this guy, it's now 0, so you can't subtract 1. So you have to borrow from this guy, it becomes 0, y, e becomes 10. 10 minus 1, 1. 0 minus 0. 0. 1 minus 1, 0, 0, 1. So you have 100111 base 2. So this is addition and subtraction in base 2. So we'll move to the next value. We have multiplication and division. So you have multiply 101101 by 11. Many of us are familiar with this kind of multiplication. You have 1 times 1. In fact, this part is very simple because anything you multiply by 1 is the same, so I really don't stress myself multiplying. I just write everything I see. So instead of saying disturbing yourself, so 1 times 1 is 1 times 0 0 times 1 1 1 0 1. The same thing but not in the same line. We have 1 times 1 1 0 times 1 1 1 0 1. The next thing you do is add. You don't add normally, you still add it in number base. So you have 1 0 plus 1 1 1 plus 0 1 1 plus 1 10. You carry 1 1 plus 1 10. Carry 1 1 plus 1 10. Carry 1 1 plus 1 10. So this is what you have. The answer is in base 2. Answer is in base 2. So this is exactly how it is to multiply numbers in base 2. You don't have much challenge. And if you think this is giving you so many challenges, giving you problem, you can convert the first number to base 10, convert 1 also to base 10, then multiply it, and then convert your answer, your final answer, to base 2. That way it will save your stress. Convert 101101 to base 10, convert 11 to base 10, multiply your base 10 answers, then whatever you have, convert it back to base 2. Although the process is long, but it's also credible, it's reliable, and it's for sure. So you have another one, 101 square. You know that squaring of a number means multiply the number by itself. So if 101 square is here and it's in base 2, in other words, what we have is 101 times 101. So 101 times 101 is 1 times 1, 1 times 0, 0 times 1, 1. 0 times anything in the world is 0. 0 times 1, 0. 0 times 0, 0. 0 times 1, 0. 1 times 1, 1 times 0, 0 times 1, 1. So we have 1, 0, 1 plus 1, 10. Then you have 1, 1. So you have 11001 base 2. This is simple because it's like normal multiplication that you are familiar with, you already know. So the only challenge is that if you don't know how to multiply correctly, which you have to practice thoroughly, so that this topic won't be a challenge to you. Now let's move to the one that scares the student most: division of binary numbers. When students see division, they get scared. They believe it's technical, it's tough. In fact, long division method from primary school have always been a very major challenge with students. Why? Because in the form of the table, and they really don't understand. You know, something you can't do on your own. You can't really fathom how it happened. But I'm going to really teach you what it takes to use long division method. Before stepping into this game, we have here 11001110 divided by 1010. I'm going to quickly do one example for you on long division. Long division has only 3 operations. There are 3 things you do in long division. First thing, okay, take for example you have 17 divided by 5 and you want to use long division method. 17 divided by 5. There are 3 things you do in long division. The first thing you do in long division is division. Then afterwards you multiply. Then subtract. These are the 3 things that we do in long division. There is no other operation under long division. Divide, multiply, subtract. Then go over again. Divide, multiply, subtract. Then go over again. Divide, multiply, subtract. You only add zeros when the numbers can't divide. You add zeros when the numbers can't divide. So let's try what we just did. Divide. 5 in 17 is 3. Now multiply. 3 times 5, 15. Now subtract. 17 minus 15, you have 2. If I want to leave my answer in mixed fraction, it will be 3 whole number and this 2 over 5. If I want to leave my answer in decimal, then I have to continue. Dividing. 5 divided by 2 is impossible because it's impossible, so I have to add 0. The moment I had my 0, something happens. I put my decimal point. The moment you put the 0, do not forget, the moment you put that 0, you put decimal point. 5 in 20 is 4. 4 times 5 is 20. Then subtract. So we just divided, we multiplied, then subtracted. So in decimal, your answer is 3.4. So we are going to use the same technique, the same process now to do these binary numbers. And we have this number we're looking at right now. We want to calculate division of binary numbers. So next page here you have 1 1 0 0 1 0 0. I'm going to use two methods here. So first, let's stick with this one. Now the first thing I want to do is I want to see this number. I know it's in base 2. Yeah, quite alright. This number is in base 2. But first, what do you see? You see 1010. You see 1,100,100. Now these are the two numbers you can see. It's in base 2, but yet let's see it that way. So automatically, you know, 1010 is smaller than 1100. So you are picking the first two figures. You are picking these figures, 1100, the first four figures. Now 1010 in 1100 is 1. What did you just do? You just divided. You just divided. What is the next process? Multiply. 1 times 1010. 1010. What is the next process? Subtract. 0 minus 0 is 0. 0 minus 1 is impossible, so you borrow 1. This one becomes 0 or 4 1. So you have 10. 10 minus 1, 1. Okay, so you just have 10 left. How do we continue? We subtract it. So we go back to the beginning, division again. 1010 in 10 is not possible. We all know that. That's way too bigger than 10. So what do? You bring down a number from the bank. Yeah, from first bank. You have 1 in your bank. 1010 in this one is not possible. It's not still possible. It's still bigger. The moment you make an attempt to step down two numbers from your bank, then you have to put 0. You have to put 0. Why? Because you brought down two numbers at the same time. You brought down 0. When you are bringing two numbers at the same time, then you have to write 0 at the top there. But when you bring just one number, then there is no reason to write 0. Just continue the division. Or if you try dividing still and it's still bigger or still smaller than the divisor, then you're going to be forced to bring down another number. The moment you are stepping down two numbers to rescue you from that place, then you have to put a 0 at the top. So 1010 is 1. You just divide it. Now multiply. 1 times 1010 is 1010. 1010 minus 1010 is 0. Yeah, don't forget, you still have one guy left in the bank. We have 0 left in the bank, so this guy is coming down. 1010 in 0 is still 0. 0 times 1010 is 0. Sorry, I can't see that. So you understand what I just did? So long division is not hard. It's not hard. The only challenge is like students don't want to attempt it. They are scared of the long division. If you know you don't want to do this, then instead of stressing yourself doing long division, you know it's giving you problem challenge, and you don't have time to overcome it, but I think you should overcome it. You should have no fear in mathematics, but if you still feel like you're not comfortable with this method, then convert 1010 to base 10. Convert this also to base 10. Divide your answers. Whatever you have, then convert it back to base 2. You are going to have the same result. You are definitely going to have the same result. So whatever you have, convert it back to base 2. What did I say? Convert 1010 to base 10. This one also convert it to base 10. Divide your answers in base 10. Whatever you have, convert it back to base 2. When you convert it back to base 2, you have the same answer we have there. I'm going to have the same answer here. So whichever one suits you best, you should try. So I gave you an exercise, something you can try on your own. Express 2203 base 4 in base 2. So I won't tell you what to do. You're already you're part of the class from the beginning, so I believe you already know what it entails to express or convert a number from one base to another. So I don't know if you have any questions. You can forward your questions to Starry Gold Academy. You forward your questions to me. My name is Manuel, and that will be all for now on number based system. Thank you very much.